Welcome to the video, How to Size and Select a Ductless Heat Pump for Displacement Applications. In this video, we will show you how to calculate the heating requirement for use of a ductless heat pump in a home with an existing heating system. This is a method developed by the Northwest Ductless Heat Pump Project to support energy efficiency rebates in electrically heated homes. This video has been produced by the Northwest Ductless Heat Pump Project, which is a program of the Northwest Energy Efficiency Alliance. NEA, as it's called, is an alliance of more than 140 Northwest utilities and energy efficiency organizations, working on behalf of more than 13 million energy consumers. NEA operates the Northwest Ductless Heat Pump Project for their member utilities and their trade ally contractors, providing training, research, technical support, manufacturer promotions, and program evaluation. My name is Jonathan Moscatello, and I've been working for the Northwest Ductless Heat Pump Project since 2018. I have a lot of experience with ductless heat pumps. In fact, the majority of my HVAC experience is with ductless heat pumps, including marketing, sales, and installation. Today I want to talk with you about load calculation, why it matters, and how to quickly and easily calculate the heating requirement for displacement applications. I'll also define displacement application and describe how it works to produce comfort and savings. Finally, I will show you how to select and right-size ductless heat pumps using the results of a load calculation. So let's get started. If you're watching this presentation, it means you are trying to do an accurate job with respect to calculating a heating and cooling load. Just like in other aspects of contracting, guesswork is not advised because it leads to callbacks, warranty work, and unsatisfied customers. You also have a lot to gain from doing it right, including saving your customers money on their equipment purchase and with subsequent energy bills. Also, proper load calculation can give you more confidence in equipment selection, which can lead to winning more projects. With this in mind, the winning strategy involves always making a calculation to determine the heating requirement. Then, knowing when a quick and easy load calculation will suffice or what a complete load calculation is required. What are the times when a quick and easy load calculation will suffice? Anytime your application involves the displacement of an existing heating source, or when you're applying a ductless heat pump to a small addition or single room, a quick and easy load calculation is an acceptable method to use. Anytime your equipment installation is intended to serve the entire home, such as during new construction or retrofit or replacement of an existing home's heating system, a complete load calculation is advised. Let's quickly review the displacement heating method, which is how we save electricity in the Northwest's ductless rebate programs. The Northwest Ductless Heat Pump Project supports the application of ductless heat pumps to save energy and make people more comfortable in their homes. Specifically, the project supports the displacement of electric resistance heat, which is produced by baseboard heaters, wall heaters, electric forced air furnaces, and ceiling heat. These forms of heating use electricity directly to produce heat, and it is 2 to 3 times more expensive to produce heat this way when compared to a ductless heat pump. Electric resistance heat is often less comfortable, too. Displacing electric resistance heat with a ductless heat pump is easy and involves 3 steps. In step 1, we identify the room or rooms in the home where occupants spend most of their time. The ductless heat pump is installed in this main living area. Ideally, this is the living room or family room. We select a ductless heat pump with the ability to take on all of the heating requirement for this main living area. In step 2, we plan to keep the electric resistance heat in the other rooms of the home and plan for its continued use as backup heat. Step 3 involves teaching the homeowner to use the old electric resistance heaters only when they feel the need to supplement the ductless heat pump. We also teach the homeowner how to properly use and maintain their ductless heat pump to achieve the best results. When steps 1, 2, and 3 are successfully implemented, a single ductless heat pump can save up to 50% on the home's heating bill. How well does displacement work? Homeowners love their ductless heat pump, with 91% of those surveyed saying they are very or extremely satisfied. Now, let's talk about how to calculate the heating requirement for the main living area and choose the right capacity ductless heat pump for maximum displacement of the electric resistance heat. The quick and easy load calculation method for displacement applications was developed by the Northwest Ductless Heat Pump Project to aid contractors in selecting and sizing equipment with the benefit of a load calculation. Our quick and easy load calculation method makes use of an innovative table of heating load factors. Through simple multiplication, we will be able to calculate the heating requirement of the main living area of a home. It is worth noting this method also works on single rooms located elsewhere in the home. The first step in applying the quick and easy load calculation method is to identify the column that applies to the home. The column represents the winter design temperature for the location of the home. If you do not know the winter design temperature, ask around or search online. Next, we identify the row that applies to the home. The rows represent several typical insulation levels found in homes. Choose the line that best applies, and it is okay to be conservative. For example, if part of the main living area has insulation and part does not, choose no insulation and just go with that. Once you have identified the row and column that apply to the home, then we know the load factor to use in our calculation. And we simply multiply the load factor by the floor area of the main living space, and we will have our heating requirement. Let's run through an example of a heating load calculation using the quick and easy load calculation method. First, calculate the floor area of the living room or main living area. Let's imagine a home with a combined eat-in kitchen and family room, totaling 500 square feet. Next, determine which heating load factor to use. Let's imagine that our example is a ranch-style home built in 1976 with little or no insulation and single-pane windows. It is located in the Puget Sound area, so the design temperature is above 20 degrees Fahrenheit. This makes our load factor 29 BTUs per square foot of floor space. Next, we multiply the room area of 500 square feet times the load factor of 29 BTUs per square feet. This results in a heating requirement of 14,500 BTUs per hour at 20 degrees Fahrenheit. The next and final step involves choosing a ductless heat pump that can provide at least 14,500 BTUs at 20 degrees Fahrenheit. Here we see several ductless heat pumps that will satisfy our heating requirement and that are readily available in most areas. What is shown are the equipment that produce slightly more than 14,500 BTUs at 17 degrees Fahrenheit. In some cases, we had to go up within the product line to find the model that produces the amount of heat we need. Why 17 degrees F instead of the design temperature of 20 degrees F? Because 17 degrees Fahrenheit is a temperature where rating info is easily found in the manufacturer's product literature. Why does this load calculation method work? This approach works because modern, computer-controlled ductless heat pumps can adjust to changing outdoor weather conditions. Thanks to this variable operation, they can also adjust to indoor load conditions within reason. This ability to adjust and adapt is the reason why we can use a simple load calculation method. The simple load calculation method is also effective because we are displacing the use of the backup heating system, which can be called upon to supplement heat during the coldest temperatures. There is a lot of built-in flexibility. And just a reminder, the quick and easy load calculation method works for single rooms and small additions too. However, do not use this method if you need to calculate the heating requirement for a whole home. This requires a complete load calculation using software. Before closing, we want to share a few important tips. First, the act of properly sizing and selecting a ductless heat pump needs to be paired with the use of recommended installation practices. In this way, a properly sized and selected ductless heat pump will produce the most possible energy savings and the greatest comfort. Research and a lot of experience has shown that installation oversights and mistakes can impact the performance of a ductless heat pump and cause it to use more energy than needed. It will also impact system reliability too. So become familiar with and always use recommended installation practices when installing a ductless heat pump. The Northwest Ductless Heat Pump Project has 2 great installer guides available for you to use. One is useful for all ductless installations, while the other contains installation practices specific to cold climates. These 2 great installer guides are available at goingductless.com. To learn more about recommended installation practices, check out the video dedicated to the subject. In this video, we discuss research findings from the Northwest and other cold climate areas on the subject of installation errors and oversights and how they impact ductless heat pump operation. We hope you will check it out. Thank you for watching.